In the previous examples, Part 1 to Part 3, we saw that there are different ways to make microstrip low-pass filters: a lumped filter or an impedance step, and a stub filter on microstrip. It is also possible to make a combination of two different filter types. Take, for example, the step impedance filter of Part 2. If the series lines of 70 micrometer are too small to fabricate, then it is also possible to not convert the inductors and use only the impedance steps for the capacitors. We will use the Chebyshev low-pass prototype filter with the first component in shunt orientation. First, select the LC values option to calculate the inductor values, then select option G values to calculate the normalized values. Next step is to transform the capacitors to its transmission line equivalent using the stepped impedance tool. For the capacitor transformation, we choose an impedance of 20 ohms. Its normalized values will be 20 divided by 50 is 0.3 ohms. Now, we can do the conversion. The values G1, G3, and G5 are the normalized input values for the capacitors. Now calculate the phase length of each transmission line. Next step is to convert the transmission lines to microstrip lines, fill in the parameters of the substrate, and fill in the impedance and phase for each transmission line. After pressing button Synthesize, the length and width of the microstrip line will be calculated. So in short, the method is: make first a lumped prototype filter, then converted it to a transmission line filter, and then choose the technology for fabricating the filter, in this case, microstrip. The followed steps are also shown in this picture, together with the simulation results of the microstrip filter characteristics.